Hi, we've been discussing analyzing risk in capital investment decisions and what are the techniques that can be used while analyzing risk. Uh, the, the risk associated with a project is essentially because of the fact that we are trying to peep into the future, because we try to forecast and estimate revenues and cash flows of a project, and because the future is uncertain, your estimations and projections are likely to go wrong. That's the inherent risk in any project. Now, how can we tide over this risk? How can we account for this particular risk? Or if not account for, adjust your calculations of NPV, IRR such that that risk is not ignored, but it is considered and due weightage is given in your analysis. So, one of the techniques of analyzing risk is a technique known as risk adjusted NPV method, right. Now, we know the traditional NPV method, but what do we mean by the risk adjusted NPV method? Let me read the case and explain this method to you all. You are told that 3 projects are available, A, B and C. The net cash outflows are given to you 1 lakh, 120 and 2 lakh 10,000. Project life for all the 3 projects is 5 years, and annual cash inflow is given as 30, 42 and 70,000. Now, let us make this assumption that project A, B and C are geographically located in 3 different locations, right. Let us say project A happens to be the host country where your company has its headquarters. Obviously, it is a known market, it is a place where you have been doing business, and hence the degree of uncertainty is low. So, the level of risk is low, right. Let us assume project B is to be executed in a neighboring country in the same continent and in and around where you are operating. Again, because of familiarity, because of proximity to your present operations, project B is not as familiar as operating in the home country, but it is not so foreign as well that you have no clue about its market dynamics. So, the degree of risk is a bit higher than project A, but it is not amazingly high such that you have no clue in terms of the market dynamics. And let us assume project C is completely in a different continent, you do not have any business connections over there, and hence you do not know the customers, you do not know the ways of doing business over there, and hence the degree of risk is highest in project C. Now, typically you are taught in finance that whenever you calculate net present value, you discount the cash inflows at the cost of capital. So, for project A, B and C, look at your funding source. If your funding is through debt, pick up the cost of debt. If you pick up the cost of debt as your discount rate. If you are funding the project entirely through equity, then discount the project at cost of equity. And if you are funding the project through a mix of equity and debt, then go ahead and discount the project at the weighted average cost of capital, WACC. Now, assuming that the funding remains the same, let us say all equity, then for project A, B and C, you are likely to discount both project A, B and the third project C at the same cost of capital. And that looks to be a little bit unfair, because that is where traditional finance principle, that is using cost of capital as a discount rate, fails, because you are ignoring the fact that higher the risk, more should be your return expectation. So, with project A, which is situated geographically in the home country, the level of risk is low and hence your expectation of returns probably are lower. But project C, which is in a completely different continent where you have never done business, obviously the degree of risk is very high and your expectation of return is also going to be high, right? Why should you take a high degree of risk and accept an abysmally low return, right? Now, if you go by this rule, thumb rule, that higher the risk, higher is the expectation of return, then by that thumb rule, your discount rates cannot be uniform for evaluating project A, B and C. So, if your cost of capital was, let us say 10%, you can't use 10% to discount project A, B and C, because your expectation of risk and returns are different across project A, B and C. So, this method of risk adjusted NPV method essentially says that adjust the discount rate according to the level of risk involved. So, since project A, B and C have a different level of risk, use a different discount rate for evaluating project A, B and C. Hence, if you notice, in the case you have been given coefficient of variation. Coefficient of variation in project A is 0.4, in project B is 0.8 and in project C is 1.2. Now, coefficient of variation in statistics is standard deviation divided by x bar, all right, mean value. Now, that is the statistical definition of coefficient of variation. In finance, CV or coefficient of variation is very clearly indicating risk. Higher the CV, more is the risk. So, if you look at the CV, it is 0.4, goes up to 0.8 and increases to 1.2, indicating that the lowest level of risk is associated with project A, highest level of risk is associated with project C and medium risk is associated with project B. So, I did give you the background that project A is in home country, project B is probably in a neighboring country and project C is in a completely different geographical and economic context, which kind of justifies the CV going up from 0.4 to 0.8 to 1.2, all right. So, essentially CV is a measurement of risk, all right. There could be different measurements of risk that a corporate could be using for its internal purpose, right. But in this case, let us assume that the corporate uses coefficient of variation as a tangible measure of risk. It could be project betas as well, right. A company could be calculating beta for project A, project B and project C, and that is how it quantifies risk, right. In this case, you are also given a table saying that if the coefficient of variation is 0, then the risk adjusted discount rate that the company uses is 10%. However, if the CV increases from 0 to 0.4 to 0.8, the discount rate increases from 10% to 12% to 14%. This allies to the logic that higher the risk, higher is the expectation of return and hence the discount rate goes up, right. Hence, a project A which had a CV of 0.4 will be discounted at 12% because the company's policy says that projects with a risk of 0.4 get discounted at a rate of 12%. Project B which has a CV of 0.8 correlates to a discount rate of 14% and project C with a CV of 1.2 correlates to a discount rate of 16%. Now, this again is what corporates will have to develop on its own in terms of the relationship between coefficient of variation and discount rate, all right. So, corporates will have to decide this relationship, that is what is the relationship between risk and return. In this we have column 1 as coefficient of variation, column 2 as a discount rate. So, the company's internal metric is, if this is the level of risk, this is the discount rate that we are going to use, right. Now, given all of this in the case, right, the solution looks like a very simple one. We are saying coefficient of variation is 0.4, right, and hence the risk adjusted rate of discount is 12% for project A, 0.8 for project B, and hence the discount rate is 14%. Project C, the risk goes up to 1.2 and hence the discount rate goes up to 16%. Obviously, you have the annuity factors at each discount rate for a period of 5 years, right, and the case also gives you the annuity or the annual cash flow. So, the annuity is multiplied with the annuity factors to get the present value of risk adjusted cash inflows. So, 30,000 multiplied by 3.605 gives you 1,08,000, deduct 1 lakh as the outflow and you get 8150. I call that as the risk adjusted NPV. Why do I call it as the risk adjusted NPV? Because we adjusted the discount rate according to the level of risk involved, alright. So, we looked at the coefficient of variation which shows the risk, and according to the coefficient of variation we selected the discount rate. So, we adjusted the discount rate according to the level of risk and then calculated the NPV, and hence this NPV is known as the risk adjusted NPV. We did the same for project B using 14% calculated inflows minus outflows leading to a positive NPV. Similarly, for project C also, right, at 16% we calculated the inflows minus the outflows and we came to the NPV, alright. Now, what we did not do is we did not use a uniform discount rate for project A, B and C. For example, I started off the discussion by saying, let us say your cost of capital is 10%, you use 10% for A, B and C. That would have been incorrect, because that means you are not including risk in analyzing the project. You changed your discount rate from 12 to 14 to 16. That was your adjustment for the level of risk. We use the logic, higher the rate of, higher the risk involved, higher is the rate of discount slash expectation of return. So, that is what the method of risk adjusted NPV is all about. Adjust the discount rate according to the level of risk and then calculate the NPV. I hope you have understood this, but I am good to take any questions either in the comments or offline as well. Thank you.